Okay, this last video will be about what they call families of functions and solving literal equations. So we'll first start with a family question. So we've got this family of linear functions, and the thing that they all have in common is that they have this y-intercept of 2. But they've got varying gradients, so some of them look like this, some of them look like this, some of them, will it be vertical? Can it be vertical? I don't think it can be vertical, because that, yeah, so that, etc., etc. So find the x-axis intercept. Well, treat these exactly the same way. So the x-axis intercept occurs when y is equal to 0. So we'll go 0 equals mx plus 2. Negative 2 equals mx. X equals negative 2 over m. All right, and so of course it would make sense that the x-axis intercept would vary depending on the gradient. Okay, so if the gradient looks like this, here's going to be the x-intercept, whereas this gradient here is going to produce an x-axis intercept of that. For which values of m is the x-axis intercept less than negative 2? So we know that the intercept is this, and we want to know when it's going to be less than negative 2. So let's drop that over to the, so we'll go negative 2, we'll go less than negative 2m. We'll reverse that, negative 2m greater than negative 2, divide by negative 2, divide by negative 2, m less than 1. Okay, find the inverse. Okay, so let's go and note that the function is y equals mx plus 2. The range and domain will be all reals because it's linear. X equals my plus 2. Okay, so now we just got to solve this thing for y. So x take away 2 over m equals y. Now inverse, so we'll just say f negative 1, x equals x over m, take away 2 over m, or you could just write it like this, doesn't really matter, where x is an element of all real numbers. Find the equation of the line perpendicular to the graph at the point with coordinates 0, 2. Okay, so the equation of the line perpendicular to the graph. So at the point, so basically the graph, so let's write down the function y equals mx plus 2. Alright, so here is one possible thing. So this will be its line that runs perpendicular. So the gradient of this, so we'll call this gradient of the original, m1, is m. So the gradient of the line that runs perpendicular, we'll call that m2, is the negative reciprocal of that value. Alright, and I know it also goes through 0, 2, so it's going to have the equation y equals negative 1 over mx plus 2. Right, so there it is there. Okay, so same y-intercept, but the gradient is going to be negative 1 on m. Alright, so this, the graph of a quadratic function passes through the points 1, 6 and 2, 4. Find the coefficients of the quadratic rule in terms of c, the y-axis intercept of the graph. Okay, so how's this going to work? So we've got 1, 6 and 2, 4. Alright, so we don't really know what the y-intercept is, we don't know what the turning point is, so all we can do is really write out these, so we can sub these into the form y equals ax squared plus bx plus c. And then because we've only got two coordinates here, what they're letting us do is write the coefficients. So write the a coefficient and the b coefficient in terms of this value here. So that means that we can solve this one even though we don't know the value of the y-intercept. So let's bang in 6(1). So we'll go 6 equals a plus b plus c. And we'll go 4 equals 2 squared is 4, so that's 4a plus 2b plus c. Okay, so what we'll do first of all is we'll get the value of, how should we do this? So what I'll do is I'm going to eliminate b first, all right? Let's just try that. So I'm going to write this top equation here, this one here, as 12 equals 2a plus 2b plus 2c. So I've just multiplied everything by 2. All right, now what I'm going to do is subtract this. Let's call this equation 1. Let's call this equation 2. I'm going to do 1 take away 2. Alright, so it's 12 take away 4 is 8. 2a take away 4a is negative 2a. 2b take 2c, 2b take 2b is 0. And 2c take away c is c. Alright, and now what I'm allowed to do, I'm going to solve this for a in terms of c. Alright, so I'm just going to do 8 take away c over negative 2 equals a. Or let's just write that as a equals c take 8 over 2. So we've got our a coefficient in terms of c. Right, so I'm going to do the same thing for these equations here, except this time I'm going to eliminate, should I do that or should I sub that for a? No, I think it's going to be easier if I just eliminate. So to do that, I'm going to multiply this top one by 4. So I'm going to go 24 equals 4a plus 4b plus 4c. Alright, and all I'll do then is rewrite this equation here as 4 equals 4a plus 2b plus c. So 1 and 2, I'm going to do 1 take away 2. So that's going to be 20 equals, eliminated, 2b, 4c take c is 3c. Alright, so I've got 20 take away 3c all over 2 equals b. Alright, so I've got my b coefficient now. So find the coefficients of the quadratic rule in terms of c, the y-axis intercept of the graph. So there's our coefficients. So our a coefficient is this one, our b coefficient is this one. And I could really write it out if I wanted to. It doesn't tell me to, but I could stick that there, and I could stick that there. Okay, and I'm allowed to do that because they said in terms of c. All right, and that's it.